Hello, everyone. Welcome back to your channel of Math and Engineering Made Easy. In today's session, I'll go back to trusses. Yeah, I know we covered trusses earlier. We did the method of joint, the method of sections. We learned how to find any zero force members. But today, I want to introduce something. It's not statics, really. It's more of a way of solving trusses, and you will see what I mean by that later. You said we already learned how to do it, but yes, I'm going to use a computer to solve a truss. I can use the calculator also, but it's a little tedious. It's the same thing, really. But here we have a truss, and this truss has a pin at A and a roller at D, and then it's subject only to a single force at C, a horizontal force of magnitude 22 kilonewton. And we want to find the force in the members. Yeah, I know. Some would say, you didn't give us the dimensions. That's a key thing. We don't care about the dimensions. This guy is crazy, so how can I find the reactions at the supports? Okay. What you are going to learn is that when you solve a truss, all what's important, notice I'm not talking about deflections like horizontal or vertical deflection of pins and joints. No. I'm only talking about forces in each member and whether they are tensile or compressive. You don't need dimensions. All what you need is either angles, so I can use sine and cosine, or slopes, which is the same thing. It's really the same thing. You say, does that make sense? So how can I find the reactions? Okay, we'll let the computer do it, okay? So if I'm given a problem like that, yeah, of course, using these slopes, I can find the dimension, but it's a tedious thing, and it's like I may make an error, and the whole thing would collapse. But using a computer or a calculator, we learn how to do it. I'm going to assume that all the reactions, I know that AX is 22 to the left, but I'm going to assume everything is positive. AX, AY, DY. And then I'm going to assume that all the forces in the members are tensile. So the arrows are going from away from the pins, away, 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 away. Then at each pin, I can write two equations, right? Two equations in two unknowns. So I will have to write 2 at A, 2 at B, 2 at C, 2 at D. And that can solve 8 unknowns. 1 force, 2 forces, 3, 4, 5, 6, 7, 8. And I solved 8 equations in 8 unknowns. You can do it manually. So in the method of joints, we go one joint at a time until we end up with 8 equations. And if we know the reactions, I only need 5 equations on top of some of the forces in the X and the Y and the moments, right? So altogether, I have 8 equations in 8 unknowns. So what's better than a calculator or a computer to solve it? And that's what I'm going to show you how to do. Also, suppose you solve it manually and you ended up, with all the correct answers and you were very proud of yourself. And then your boss comes and say, oh my God, the other engineer, when calculating the forces, made a huge mistake. These 22 kilonewton are not applied at C, but at B. Oh my God. No, I'm not. I'm going to resign. I'm not going to do all this manual calculations again. But you will see with a computer, with it just single change, you get it. So no matter what like loadings you will get, it's so easy to calculate. You just change something and solve. So I'm going to write 8 equations in 8 unknowns, and they are very simple. So let me go to Microsoft Excel, and I'm going to use maybe this row for the members and this column for members. So I want to make them maybe bold and red. And I'm going to write all the members that I have. So if we go back, I have AB and AD, and then BC and BD, and then CD. So I'm going to write those. AB, AD, BC and BD, BC and BD, and then CD, and then A sub X, A sub Y, and D sub Y. These are the 3 reactions. Maybe I will zoom a little bit if you don't see it properly on the screen. Oh, I have to enter this first. And then here, I'm going to write the right-hand side because every equation has equal and then right-hand side. Also here, I'm going to write the 8 equations. I have A sub X. Don't confuse it with A sub X as the reaction. This is just the summation of the forces in the X direction at joint A. A sub Y, BX, BY, CX, CY, DX, and DY. In fact, the answer, maybe I will have to have the answers here. So I'm going to copy these and paste them on here, but as a transpose. So instead of being in horizontally, they would be vertically, and I will get the answers here. I'm going to color these in yellow so you see that the answer would be here. Okay, now I need to write the 8 equations. Notice in the X direction, I have AD, and then notice, oh, we didn't complete the triangles. 3, 4, everybody knows it's 5, right? That's Pythagoras. 3, 4, 5. 5, 12 would be 13. Remember, I had quickly told you how to construct a Pythagorean triangle with any odd number. You square it, you get 25. What 2 numbers that consecutive numbers that add up to 25? Yeah, 12 and 13. So this is 1 and 3. Now 1 and 2, that's 4 and 1 is 5. So that's square root of 5. So now I have everything. If I want to write the X component of this force, it's 4 over 5. Horizontal over inclined. It is inclined with the 5. This is horizontal with the 4. So 4/5 of the force. If I want the vertical, it's 3/5. But when I come to the B, it would be negative 4/5 as a horizontal and negative 3/5 as a vertical. At the end of the day, when you sum all the columns for members AB, AD, BC, BD, CD, you will get 0. Because if it's positive X and positive Y here, it would be negative X and negative Y here, and so on and so forth. So trust me, I mean, you can take a picture of that because I'm not going to split the screen. I'm going to go to Excel and write the equations right away. So AX, I have for member AB, I have 4/5, so I can enter 0.8 or 4 over 5. AD, all of it is to the right, so I write 1. There is nothing else except AX, right? And the rest are zeros. So I'm going to write 0, 0, 0, oops, 0, 0, and there is no right-hand side because there is no external forces. AY, the AB has a 3/5, which is 0.6 or 3/5, but AD doesn't have any component vertically because it's a horizontal member, right? AD is a horizontal member, so it doesn't have a Y. only I have a 1 here, but I can write a 0, fill to the right, 1 and 0. And I can fill in this with the zeros. For now, there is only one external force. Now, when I go to Bx, in the X, I have 3 forces. There is 4/5 of BC and negative 4/5 of AB, and then a positive 1/√5 for BD. So let's enter these. AB, I have negative 0.8. AD is not, only what they have a B letter. So this is 0. And then for the BC, it's the same as AB in the X. It's 4/5, which is 0.8. And then BD, it's positive 1. So I'm going to write equals 1/√5. There is not, let's make these only. Yeah, 2 decimal places is good enough. There is no B here. There is no, but there is nothing here. And there is nothing here. Now I go to the 4th equation, By. Again, I have BC is positive, AB is negative, BD is negative. Only 3 values. So negative 3/5 for AB, negative 0.6. Notice that I have a negative 0.6 and a positive 0.6, 0.8 and 0.8. And after that, it's C and D, so there is no letters A or B, so these would be zeros. So this column add up to 0. Now, for AD, there is nothing because the letter B is not there. The Y of BC, is 3/5 or 0.6. I'm going to write 0.6. For BD, the Y is negative. For BD, the Y is negative 2/√5. So negative 2/√. Will it accept it, or do I have to say equal? I think it will accept it because there is no confusion. If it's a fraction like 3/5, it may think that's a date. And then there is no B's here. So we are not going to get stung. Oh, okay. Bad joke, of course, as usual. CX, here you have to be careful. First of all, I have negative 4/5 of BC and negative 5/13 of CD, and then I have a positive 22. But 22 is a constant. I'm going to move it to the right-hand side, so I'm going to enter it as negative 22. Do you see that? The reason I write it as negative is that I'm going to move it to the right-hand side of the equation. Only variables are on the left. So for CX, for BC, it's negative 4/5 or negative 0.8. And then for BD, of course, there is no B. We are in the C, so that's a 0. And then when I go to CD, we said it's negative 5/13, so equals negative 5/13. I think if I say 5/13, it won't accept it. And then 0, 0, 0. But when I come here, I say negative 22. Okay, negative 22, because as I said, we are going to move it to the right-hand side of the equation. So this equation would read negative 0.8 BC minus 0.38 CD equals negative 22. Okay, CY. Again, CY, I have 2 forces, only 2 forces. Negative 3/5 at BC, so negative 0.6. Notice negative 0.6 and positive 0.96, negative 0.8 and positive 0.8, they cancel each other. So the sum of this column also would be 0. BD, we said it's going to be, no, there is no BD, I meant CD. CD, it's negative 12 over 13 equals negative 12 over 13. 0, 0, 0. dx. Here is the d. dx, we have a lot. We have 5 over 13 positive, negative 1, and negative 1 over root 5. So for AD, it's negative 1. Again, positive 1 and negative 1, they cancel each other. BC, there is nothing. BD is negative 1 over square root of 5. I didn't need to say equal, but it doesn't harm. And then CD is positive 5 over 13 equals 5 over 13. And then 0, 0, oops. Zero, zero, zero. And finally, that's the last line. And I keep going back and forth, but if you are doing it yourself, you wouldn't lose that time. In the Y, I have 3 things. I have BD, 2 over root 5, CD is 12 over 13, and DY is 1 going up. Okay, only the external forces, I changed their signs. I found this on the web. Oh my God, this is, I think my phone thought, Siri thought I'm asking a question. I'm so sorry. Oh my God. So AD doesn't have a vertical component. BC doesn't. BD, we said BD is 2 over root 5. So equals 2 divided by the square root of 5. And again, 0.45 and negative 0.45. Negative 89, positive 89. They add up to 0. CD vertically is 12, 13. So equals 12 over 13. Again, negative 92, positive 92. Negative 38, positive 38. That should be your way of checking that for the reactions, the sum should be 1. But so I can say sum of this column and then fill to the right. I should get a bunch of zeros followed by 3 ones. Okay, and you can see here, you can make them bold, and maybe with another color. Okay. Alrighty, now I want to solve. If you have 8 equations in 8 unknowns, you learn in linear algebra to solve for x, you need to do the inverse of A times B. Oh my God. Okay, I keep throwing pens. I don't know why they finish. So how do I write that in Excel? We learned that. It's no big deal. There is a function called MINVERSE for matrix inverse. And if you don't know it, you type few letters and it will show you all the functions, and you can click on it and open a window that tells you exactly what you need to fit. But before doing that, I need to multiply 2 matrices. So I have to say equals MMULT for multiplication. It asks you, what is your first array? You say, okay, the first array is the inverse of A. So it's M inverse of the matrix A, which you will drag it and do the 8 by 8 matrix that we filled with zeros and a bunch of numbers, right? Comma, B, which is the right-hand side. This is the right-hand side. And that will give you the answer right away. You see how easy? So really the tedious part is entering the data. And notice here, I didn't care about the dimensions. How long is this number? I don't care. If I make the same shape 100 times larger, I will get the same matrix on the left. All what changes is the right-hand side. So when I told you, suppose the 22, instead of being to the right at D, at C, it's down at B, and it's completely different. So when I go to BY, I will enter it here. I will enter it here with the opposite sign. So if it's going down, I will enter it positive 22. If it's a different number, I will enter that number. If I add another force somewhere, I keep adding it or deleting it at my wish. And the beauty of it is that that's the only thing I need to change. Notice, first of all, you have to select the whole area before entering the equation, because if you just select the first one, it will give you the result of the first member. Doesn't make sense. I want to solve all together, or why am I using a calculator? So I'm going to say equals MMULT. See, when I type MMULT, suppose I click on MMULT, it will tell me, oh, you need to find the first array, comma, second array, and close the parentheses. I was using brackets just because I use bracket first, but use parentheses, of course. The first one is not an array. It's the inverse of an array. So I'm going to say M inverse. You see, it will tell you, okay, which array? Now you give me the array. Oh, here it is. And then I'm going to close the parentheses, do the comma to enter the second array, which is the right-hand side, and then close everything. I'm done. Again, if you click enter, you will get the value of AB only. You have to click Shift Control and then enter to get all the results simultaneously. So that's the only thing you need to remember. Shift Control, enter, I get everything. So AB is for 40 kilonewton tension, AD is 10 kilonewton compression, BC is 40 tension, BD is a zero member. You should have seen that. Okay. You can see that at join D, these two members are collinear, so the third is zero. We learned that. So we could have just deleted that, but Excel or the computer or the calculator will tell you that. These three forces are compressive, 26, but AX is 22 to the left, AY is 24 down, and DY is 24 up. I'm done. So if I want to change, as I said, suppose the vertical force was down at B instead of this, I had that. I no longer, like when your boss told you, you don't need to resolve the problem. You have to go to the BY equation, BY, and enter positive 22 and come down and write 0. And now you have the new forces. And you go to your boss like a minute later and you say, okay, here is the, you say, what? How did you do that? You say, well, that's my secret. I'm not going to tell you unless you give me a raise, but okay. Yeah, letting jokes aside. Oops. So that's basically it. I hope you liked it. And again, as usual, if you have any comments or questions, please be my guest. Leave me a line and I will get back to you as soon as I can. Thank you very much for your time. Hope to see you soon. Have a great day. Bye. Oops. Oh my God. Okay. Why? Okay, bye.